a little bit of review of determinants. For 3 by 3, remember the easiest way was to rewrite 2 more columns, then make 3 diagonals. The green lines would be added up and be just positive, and then the red ones, you add those ones up, but then you have to subtract. Much easier, I think, than this formula for remembering it. So as a warm-up, we could find out the determinant of this matrix. I would add my columns there. And then draw my diagonals, figure out that number. Draw my diagonals in the other direction. And then the blue numbers add up to 8, minus 53, and we have a determinant of negative 45. And again, if your determinant is not equal to 0, then an inverse exists. But the nice thing about 3 by 3 matrices is we are totally going to be reliant for the inverse on our calculator. So you won't have to do any complicated inverse math for 3 by 3s. There is a 1.5-page technique that you can use. Happens to use the transpose, which we don't use, and we got introduced to it where you switch the rows and the columns, but you don't need to use it anywhere. So this is sort of a problem-solving application of knowing that if your determinant is 0, the inverse doesn't exist. So we set this one up, and it says, given this matrix, determine a value of x so the inverse doesn't exist. And what I'm going to do is I'm going to find the determinant. I'm going to find that determinant, and I'm going to set it equal to 0, and then hopefully I have an equation where I can solve for x. So if we draw our diagonals this way, you will get 4x minus 2. If we draw our diagonals this way, I love when a diagonal has a 0. You will get just x minus 16. And if you set that equal to 0, it's not hard to solve and find out that if x is negative 14 over 3, then the inverse doesn't exist. Way better than trying to guess and check. Now for inverses, for 3 by 3s, all we are going to do is type it into the calculator. And so let's just pretend we've typed one in here. Let's look at our matrix. In matrix A is already a 3 by 3. If I want to find the inverse on a calculator, all I have to do is type in matrix A and then hit the little -1 button, and it will calculate the inverse for us. Usually it comes out to a fraction, so then we can hit the math button and change it to a fraction, which makes it much easier to use, or to write down your answer. So for this one, if we did the same thing, that would be the inverse. And since in matrices there's no dividing by 0, or dividing by any matrix, and there's no dividing by 0 anywhere, since that you can't divide any matrices, when you're solving equations, you're always using an inverse. So for part B here, it says find P if A times P equals B. The only way we can get rid of something in an equation is by multiplying it by its inverse. And this is the one little part that is tricky, is that if I'm going to multiply this A by its inverse, the inverse has to be in front. But if I multiply in the front on this side, I have to multiply in the front on that side. That's a key difference in matrices than any other math you've done so far. Where things are multiplied, the order matters, so we have to maintain that order. If you multiply in the front on one side, you have to multiply in the front on the other side. And then it would just be a matter of, I would type in matrix B into my calculator, I would type in matrix A, and I would go A inverse times B. I type this exact thing into my calculator, and you get your answer from that. Here somewhere. There it is. But where matrix equations and inverses are really nice is when we get to solving 3 by 3 equations. So if we're looking at A, what we can do is we can make a matrix with all the coefficients, somewhere here. When I decided to use the invisible white boxes, I realized that that's not as good as when I use the not invisible orange boxes. Because the orange boxes is really obvious where you can push the button to make it appear. So I make a matrix with the coefficients. I make a matrix X, which is just my variables matrix. And I make a matrix B, which is my answers matrix. What's nice about this is we can type matrix A into our calculator, type matrix B into our calculator, and then mathematically, all we need to show is that, okay, so matrix A times matrix X equals matrix B. That's our equation turned into matrices. And if I want to solve for X, all I need to do is multiply the fronts of both sides by A inverse. And this is all calculator, and typing in A inverse times B gets your solution right away. So with a calculator, this is nicer than substitution or elimination. Of course, there are a number of nice apps online or things where you just take a picture of the question and it solves it for you. Those kind of apps love systems of equations because they're really easy for those things to do. So I want you to try part B on your own. set up the equation, type it into your calculator, and solve.